Okay, so I'm not at school today, so we're going to do this on a recording. We're going to talk today about the definition of a rational expression, the introduction to rational expressions. We'll start with the definition of a rational expression. We've been studying polynomial functions, and you learned that a polynomial function was anything that could be written as p of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 plus a sub 2 x squared plus a sub 1 x. This. Oh, goodness gracious. A sub 1x plus a naught. Well, a rational expression is one that can be written as r of x, where this is a quotient of two polynomials. There'll be some expression like this, p of x divided by another expression like that, q of x. Any algebraic expression that can be written like this is an example of a rational expression. Sometimes they're easy to see. X squared plus 2x minus 1 over x plus 1, or x plus 1 over x squared plus 2x minus 1. But sometimes they can be written as numbers or variables plus a rational expression that looks like that. So another example would be this, 2 plus 1 over x minus 1. I'll show you in just a little bit when we get to the rewriting rational expressions how we can write this in this form. But anything that can be written in equivalent form, where it's p of x over q of x, where p of x and q of x are both polynomials, that's a rational expression. If we want to find the domain of a rational expression, this is all the possible values that we're allowed to plug in for x. The domain of all real numbers except values that make the denominator 0. Denominator in any fraction we have to take out of the real numbers. If we had the rational expression x plus 2 over x minus 1, its domain is all real numbers, negative infinity to 1. We have to take out 1. All real numbers except 1, joined with or union 1 to infinity. That's seized by the 1 because we're taking it out, it's not included. If we had x minus 1 over x plus 2, that domain is all real numbers except negative 2. So negative infinity, then negative 2 excluded, and negative 2 excluded to infinity. Sometimes the rational expressions are a little more complicated. So say we had 2 plus 3 over x minus 5. Then that domain, we still take the denominators and set them equal to 0 and solve. Exclude those numbers from the domain. So this is negative infinity to 5, joined with 5 to infinity. Let's see. We might have to add another page here. Another example may be where we have a higher degree polynomial in the denominator and we have to use our essential life skill of factoring. So let's say we have x plus 2 over x squared minus 9. In this case, we're going to rewrite this a little bit. We're going to factor everything we can factor. We don't cancel anything out if we're going to find the domain. We just factor. X squared minus 9, you should know, is factors to x plus 3 times x minus 3. And that means if we plug in negative 3, or if we plug in 3, that's going to make the denominator 0. So our domain here is all real numbers except negative 3 and 3. And we write that from negative infinity to negative 3 because negative 3 is the smaller or the lowest number of the two, joined with negative 3 to 3, joined with 3 to infinity. Let's try another one. Let's do x plus 1 over x cubed minus 3x squared. Oh, sorry. Yeah, that's good. Minus 4x plus 12. I need to factor the denominator. Remember, we factored these in the last unit when we did on polynomials. This is the same as x plus 1 times. I can factor this by grouping. And I pull up the x squared in the first group. Pull up negative 4 in the second group. This becomes x plus 1 over x squared minus 4 times x minus 3. And that's equal to x plus 1. And I know that x squared minus 4 factors to x plus 2 times x minus 2 times x minus 3. And that means I have to take out negative 2, positive 2, and positive 3. So my domain is from negative infinity to negative 2, join with negative 2 to 2, join with 2 to infinity. And that's how we do domain. The next we're going to look at is writing a rational expression in equivalent form, where it has a common denominator, and we're writing an expression like this as some expression where we have a polynomial divided by a polynomial as a single fraction. And the way we're going to do this is with common denominators. So I have a denominator of x plus 2 in this fraction. I need a denominator of x plus 2 in this fraction before I can add the two together. So the way I'm going to get that is I'm going to multiply this fraction by a very particular number 1. X plus 2 divided by x plus 2 is just 1. So I'm going to multiply this first number that doesn't have an x plus 2 in the denominator by x plus 2 over x plus 2. And that's going to give me x plus 2 over x plus 2 plus 1 over x plus 2. When I add fractions, I add the numerators, keep the same common denominator, so I end up with x plus 3 over x plus 2. And that would be an equivalent form of my original 1 plus 1 over x plus 2. If you'd like to try to plug in numbers, make that to test that, you can choose a number for x, plug it into the circled expression, and plug it into the original expression and see if those come out equal in the calculator. Let's try another one. Let's do one we have two fractions with variables in the denominator. Let's do 3 over x plus 1 minus 2 over x minus 1. Now, I need a common denominator. Notice that I have an x plus 1 in this fraction, I have an x minus 1 in the denominator of this fraction. That means I need a factor of x minus 1 over here. So I'm going to get that by multiplying numerator and denominator by x minus 1. Over here, I need a factor of x plus 1 in the denominator to get a common denominator. So I multiply numerator and denominator by x plus 1. When I multiply these two fractions, remember I multiply straight across, numerator times numerator, denominator times denominator. So I get 3x minus 3 over x squared minus 1 when I multiply x plus 1 times x minus 1. Now it's minus, then I multiply this fraction together, and I get 2x plus 2 over x squared minus 1. Now I subtract two fractions to have a common denominator. I'll take the numerator of the first and subtract the entire numerator of the second and keep the same denominator. And so now I'll simplify the numerator, and I get 3x minus 3 minus 2x minus 2 all over x squared minus 1. And that's equal to 3x minus 2x is just x, and negative 3 minus 2 is minus 5 over x squared minus 1. And that's equal to my original expression of 3 over x plus 1 minus 2 over x minus 1. And that's the equivalent expression. That's a short lesson on how to define a rational expression, find the domain of a rational expression, and rewriting a rational expression in equivalent form with a common denominator, or instead of a single fraction with a common denominator. So y'all try that, try the assignment I gave you on edge elastic, and we'll see where we're at with Tuesday.